Welcome everyone to today's Explainer. We're diving into something with absolutely massive stakes today. I'm talking about the intense, highly regulated world of forensic toxicology. This is a universe where people's livelihoods, their safety, and sometimes literally their physical freedom are entirely on the line. Every single day, millions of biological samples get collected, sealed up, and shipped off to labs just to answer one crucial question: is there evidence of drug or alcohol use? But, how exactly do we get from a simple plastic cup to a legally defensible, undeniably scientific verdict? Let's find out.
Okay, let's dive right into this. Today we are following a sample from the exact moment of collection straight through to the final verdict. We're going to cover the high stakes and strict rules, choosing the sample, catching the cheaters, taking a look inside the toxicology lab, the science of breathalyzers, and finally, the final human verdict.
So Part 1, high stakes and strict rules.
Before a single drop of science can even happen, the legal foundation has to be poured by federal bodies. We're talking agencies like SAMHSA and the DOT. A forensic drug test is absolutely not your casual clinic visit. If a sample is going to hold up in a court of law, or, say, determine if a commercial airline pilot gets to keep flying, the collection protocol has to be totally ironclad. It's all about protecting the legal chain of custody. So it starts with prep. The collector literally has to open a clean, completely unused container right in plain view of the donor. No hidden tricks. Then, in federal testing, we do what's called a split specimen collection. The donor gives the sample, and it's poured into two separate bottles. Bottle A, the primary one, gets at least 30 milliliters. Bottle B, the backup, gets 15. This is actually brilliant because if there's ever a dispute down the road, there's an untouched, sealed backup ready for retesting. And then the clock starts. The collector has exactly 4 minutes, just 4 minutes, to verify the specimen's temperature.
And that temperature window is incredibly narrow, exactly 90 to 100 degrees Fahrenheit, or about 32 to 38 degrees Celsius. Why so specific? Well, because that is the exact physiological temperature of human urine the moment it leaves the body. If that temp reads even a little bit outside this exact window, the collector immediately has a major red flag. They have reason to believe the sample was tampered with. Maybe the person swapped it for synthetic urine they had hidden in a pocket. The consequence for that? An immediate recollection. Only this time, it has to be done under direct physical observation. No privacy.
All right, Section 2. Choosing the biological sample.
So, shifting gears from the rules to the actual biology, how does a lab even decide which part of the body to test? Well, toxicologists call these materials biological matrices, and choosing one is a very strategic move. Urine is pretty much the workhorse of the industry. It gives a detection window of about 1 to 7 days, it's totally non-invasive, and drugs concentrate really heavily in it. But what if you need to know if someone used drugs literally a few hours ago? That's where oral fluid or saliva steps up. Oral fluid is perfect for catching very recent use, spanning a tight window of just 5 to 48 hours. Plus, you can sit there and watch the collection directly, which makes it super hard to fake. On the complete opposite end of the timeline, we have hair. Human hair grows at roughly 1.3 centimeters a month, and as it grows, it actually traps drugs from the bloodstream right inside its core. A standard hair sample can give labs a massive 90-day historical record. And get this, labs actually wash the hair with special solvents first, just to make absolutely sure they're testing what the person ingested and not just, secondhand smoke from a crowded concert.
Moving on to Section 3. Catching the cheaters.
Wherever there are massive stakes, you're going to find people trying to beat the system, right? So it begs the big question, can you actually cheat a modern drug test? If you look online, you'll see hundreds of products promising to magically erase your drug history. But here's the reality. Forensic labs know all about these tricks, and they've developed some seriously advanced countermeasures to catch deceptive donors right in the act.
They use something called specimen validity testing, and it runs simultaneously with the actual drug test. First up, the lab checks creatinine. This is just a natural byproduct of your muscle metabolism. If that creatinine level drops below 2.0 milligrams per deciliter, the lab knows instantly, boom, this liquid is biologically incompatible with being human urine. It's totally fake. Next, they check specific gravity, essentially measuring the sample's density against pure water. Then comes pH. Normal human urine sits between 4.5 and 9.0 on the pH scale. If that drops below 3 or spikes way up past 11, the lab knows for sure you dumped something harsh in there, like bleach or vinegar, trying to destroy the drug molecules. And finally, they actively hunt for chemical masking agents, like nitrites, which are common in commercial products sold specifically to hide marijuana use. You simply can't just trick the machine anymore. The lab literally interrogates the basic chemistry of the fluid itself.
Okay, Section 4. Inside the toxicology lab.
So, once a sample proves it's legitimate and passes all the cheater checks, how do they actually find the drugs? Well, their first line of defense is the immunoassay. Think of this as a rapid, cost-effective initial screen. It uses biological antibodies that are specially designed to lock on to specific drug molecules. It is fantastic for churning through thousands of samples a day. But it has one fatal flaw: cross-reactivity. See, the antibodies aren't absolutely perfect. Sometimes they get confused by totally legal substances that just happen to look structurally similar, like common over-the-counter cold medicines, triggering a massive false alarm. Because of this exact issue, an immunoassay by itself is never ever enough to secure a legally defensible verdict.
Any sample that flags positive on that initial screen has to be sent out for confirmation, and they do this using mass spectroscopy. Now, for decades, the absolute gold standard was gas chromatography mass spectroscopy, or GCMS. But GCMS is kind of like baking. It requires the sample to be vaporized at really high heat. That means you have to do extensive, time-consuming preparation just to stop the delicate drug molecules from literally burning up. Fast forward to today, and modern labs have largely upgraded to liquid chromatography tandem mass spectroscopy, or LCMS/MS. Instead of superheated gas, it uses a liquid mobile phase. It's way faster, requires barely any prep, and it can easily test complex, unstable molecules. This machine literally shatters the drug molecules apart and measures their exact fragments, giving the lab a 100% unique, absolute chemical fingerprint.
The really crucial thing to understand here is just how insanely sensitive these mass spectrometers are. They don't just give a simple yes or no, they quantify the exact amount of the drug. The federal guidelines set very precise molecular thresholds, which we call cutoffs. For example, to be officially confirmed positive for the marijuana metabolite THCA, the machine has to detect at least 15 nanograms per milliliter. For cocaine, it's 100. Amphetamines are 250, and opiates are 2,000. Now, to really put that into perspective, a single nanogram is 1/1000th of a gram. 1/1000th! These machines aren't just testing liquid, they are quite literally counting molecules.
Moving on to Section 5, the science of breathalyzers.
We've been talking a lot about analytical chemistry, but breath alcohol testing requires a total pivot over to physical science. Have you ever wondered how blowing a puff of air into a plastic tube actually tells a police officer what's floating around inside your veins? It all comes down to a fundamental principle of physics called Henry's Law. Basically, Henry's Law states that in a closed system at a constant temperature, the concentration of a volatile substance, like alcohol, dissolved in a liquid is directly proportional to its concentration in the vapor floating right above it. So when you breathe in deeply, the deep alveolar air at the bottom of your lungs comes into incredibly close contact with your blood supply. The alcohol naturally evaporates out of your blood and right into that breath vapor. So by measuring the alcohol in that deep lung air, we can accurately calculate the alcohol running through your blood.
To actually crunch the numbers, breathalyzers rely on a standardized mathematical formula called the partition ratio, which is set at 2100 to 1. This ratio assumes that 2100 milliliters of your exhaled breath contain the exact same amount of alcohol as 1 milliliter of your blood. Now, this is widely accepted across the board, but it is heavily debated by scientists in courtrooms all the time. Why? Well, because your body isn't a perfectly calibrated machine. For instance, for every single degree Celsius your core body temperature rises, your breath alcohol reading can falsely jump by up to 7%. Even your hematocrit, which is the ratio of solid particles to liquid in your blood, can significantly skew the math. To actually measure that breath, law enforcement essentially relies on two main technologies. Back at the police station, they use infrared spectroscopy. These are the big, heavy-duty machines. They literally shoot infrared light straight through your breath sample. The alcohol molecules absorb specific wavelengths of that light, and the machine just measures whatever light is missing on the other side. Out on the side of the highway, though, police use portable fuel cell sensors. These handheld devices rely on a direct chemical reaction. The alcohol actually oxidizes on a little platinum electrode inside the device, which creates a tiny electrical current. The more alcohol in your breath, the stronger that electrical current gets.
Which brings us to our final section, the final human verdict. Look, we've just seen millions of dollars worth of automated tech, brilliant physics, and pure chemistry. But at the end of the day, delivering true justice requires a human mind. There is a massive misconception out there that we absolutely need to clear up. Simply finding a drug molecule in someone's urine or hair does not automatically mean they are actively intoxicated right in that moment. A positive lab result really just proves molecular presence within a specific window of time. I mean, you could test positive today for a drug you consumed 2 whole weeks ago while on vacation, long after any actual impairment has completely faded away. The machine is incredibly smart, but it only tells us what is there. It has absolutely no idea why it's there.
And that perfectly sets the stage for the final hero of our journey, the Medical Review Officer, or the MRO. The MRO is an independent, fully licensed physician who steps in as the ultimate gatekeeper of the whole process. Before a positive result is ever handed over to an employer or a government agency, the MRO gets involved. They actually sit down and interview the donor. They hunt for legitimate medical explanations, asking things like, hey, do you happen to have a valid prescription for this opiate from a recent surgery? They are also experts at interpreting bizarre metabolic conditions. For example, did you know that certain totally normal Parkinson's medications can actually metabolize into illegal methamphetamine inside your body? The multi-million-dollar mass spectrometer has no clue about that, but the MRO does. They are the ones who translate all that raw, rigid data into a legally sound, completely fair verdict.
So I want to leave you with this final thought. As designer drugs just keep evolving and our lab equipment gets even more insanely sensitive, where does the ultimate truth really lie? In a world of flawless algorithms and multi-million-dollar machines calculating single nanograms, is the perfect test truly a matter of absolute chemistry, or does it require absolute human judgment? Thanks so much for joining me on this explainer today, and hey, keep questioning the science around you.